How many times has this happened to you?
Okay, today class we're going to talk about the quicksort algorithm. Now, as you can see here, you begin by using the find pivot function to find a pivot. You will then take that pivot value and partition the array into two parts, one with the hello values and one with the hi values.
What?
You'll then use the quicksort algorithm again recursively to sort each of the two parts. Simple, right?
I really don't understand.
So, show me, where would the indices stop moving in?
Here.
All right, I think you understand it now.
Yeah, I think I do. I think I've got to run actually, so thank you very much for your time.
Right, we've been at it for quite a while.
This was really helpful. Do you think we could do this in class?
Well, unfortunately, to do this in class, I'd have to get everything worked out in PowerPoints, and it's really hard to make all those pictures to show how something's sort of moving around in the algorithm like that.
Oh well. Okay, well, thank you again for your time.
All right, you're welcome. Let's see if there's anybody else waiting for me out here. You know, my students, they just don't get it. I mean, they do get it when I sit down with them one by one and go over it, but that just takes too long.
My students don't get it either.
Have you thought about using an algorithm visualization?
That's a good idea.
Yeah, that might be a good idea. You know, I've been thinking about that for years. Maybe I'll actually try that next semester. All right, looks like I better start getting ready for the data structures class this fall. That lecture on quicksort is coming up tomorrow. I guess it's time for me to find a good algorithm visualization to use. Now, where am I going to find one?
Okay, so let's see. I want to learn Java, so I need some kind of project to help me work on this. Quicksort. Yeah, I had a lot of trouble with that last semester. Maybe I can write the visualization for this.
Okay, I'll search for one. Now that one's not an AV, and that's not either. Here we go. Algorithm visualizations on sorting.
Maybe quicksort's a little difficult for my first visualization, first project in Java. I'll start with maybe bubble sort. That was a lot easier.
Bubble sort. Another bubble sort. Why are there so many algorithm visualizations for the simple sorting algorithms and not the complicated ones that the students need most? There we go. Quicksort algorithm visualizations. Now let's see if any of these are any good. No, I don't like that one. No, that one neither. Eureka! I found one that I can use. I think I found a good algorithm visualization I can use in my quicksort class tomorrow.
That's great.
Yeah.
How do you plan to use it? Will you use it as a lecture aid?
That sounds good.
As an in-class exercise where students work through it? Or a out-of-class support? How does it match the algorithm and presentation in your textbook? How does it relate to your test? What will you do for your other sorting presentations? Can you use the same examples that you're used to? Will it work on the laptop and projector screen in your classroom?
I don't have time for all of this. I don't have time to work this out before tomorrow. I wish there was some place that I could go to find out about this stuff, right? Some place where they've already done this and they tell me what to do. Oh well, maybe next semester. So I was able to use that quicksort AV in my class yesterday after all. The students really liked it.
Nice.
You know, but I don't have anything to follow up with. And you need so many algorithm visualizations to cover the whole semester.
Well, I guess what you can do is collect or create them over the years as you have time and slowly build up your repertoire. That isn't too different from how we develop our materials now.
I guess so, but each of these AVs would be used for such a small part of each class. And you need so many of them over the course of the semester, and they have to fit in with the rest of your materials. That's assuming you can find a good one that's already out there. You don't have to do it yourself.
I don't think anyone would fault you for not using them. I know many professors who don't use AVs probably for the same reason.
Yeah, sure, but my students still struggle with understanding this material from the lectures and the course notes. It takes so long to teach each student one by one. When I used the algorithm visualization, it really seemed to help and the students really liked it. But there's so much work in getting them started with using one. I wish there was some place I could go to get more information.
You know what I would like? I'd like a way to tell the AV developers what I need and what works.
You know, I saw this site the other day, AlgoViz Portal. They have a big catalog with hundreds of AVs sorted by topic.
Yeah, I've seen that too. It's great. But, you know, so many of them are on simple things like, you know, linked lists and bubble sort. We don't need AVs on those topics. I can't find many on the harder topics that the students really have trouble with.
See what I mean? If we could just tell the developers what we need, and if they knew what was out there, then they would quit reinventing the wheel and start making better visualizations.
Okay, fellas. Well, I've been looking at the AlgoViz portal's catalog of algorithm visualizations, and I've identified 10 areas where more AVs are needed. Now, Mike and I have worked up some mock-ups for what we think they would look like, and I think we've got some great ideas. So, I mean, we're all ready to start implementing.
That's great. But I've been thinking about this, and aside from all the issues related to coming up with a good AV, there are a lot of other things that we need to think about for this project. How are we going to license this? I know that we want to make it open to everyone to use and improve on, but what's the right way to do that? With so many open source licenses, it can get really confusing.
Yeah, I'll say. And this is going to be a really big project, you know, bigger than something I've ever done for a class or anything like that, so we're going to have to do a lot of organization.
Right, and what about supporting materials? Do we need to include instruction sets, guides, or tutorials?
Yeah, boy, that is a lot to think about. I was hoping we could just implement some of these AVs and we'd be done. But it looks like there's a lot more we have to deal with. I wish there was a way to get some more information or maybe some help from people who've done this before.
Yeah, and it would also be great if we could get feedback from instructors and students as we go, and if we could get help evaluating what we develop.
I think a lot of this is already on the AlgoViz portal.
The AlgoViz portal is designed to help the computer science education community find and use algorithm visualizations. The catalog has nearly 500 algorithm visualizations organized by category. Registering at the site is easy, and it allows you to rate and comment on visualizations. Forums allow users to interact with one another. Field reports let instructors tell about their real experiences with AVs in the classroom. And finally, developers can get help with many aspects of AV development. We invite you to join the AlgoViz community at algoviz.org today.